In this video, we're going to be balancing redox reactions. If you look at this equation right here, cobalt and nickel forming into cobalt and nickel, it looks like they're both balanced by moles or by mass, meaning there's one cobalt here, there's one cobalt here on the right side, and then we have a nickel, and then there's a nickel on the right-hand side. But the thing is, it needs to be by both mass and by charge. And you'll notice that you might notice, maybe not, but it is balanced by mass, by mole to mole ratio, it is balanced, but not by charge. There's +3 here, there's +2 here, so, and there's nothing over here, and there's +2 here, and it's definitely not balanced by charge. So what do? We are going to take this particular equation and we're going to split them into half reaction and balance the charge. Now, when we split them up into either oxidation half reaction and reduction half reaction. So on the oxidation side, we're going to do an oxidation reaction. On the right side, the reduction, we'll put reduction half reaction. So let's go ahead and do one of them. Let's start off with reduction. So in the reduction half reaction, we're going to go ahead and take nickel solid. And then you're going to find its counterpart. Well, its counterpart is kind of easy. It's the nickel 2+. So arrow, nickel 2+. Now let's go ahead and look in the right side of the equation and the left side of the equation. In the left side of the equation, there are no charges, 0. On the right side of the equation, there's a total of +2 charges. So where am I getting these charges? Well, I'm getting it from the compound or the element in itself. So nickel has no charge. You don't see any charge on the subscript. Whereas over here, you see a charge of +2. So what happened here? It went from 0 to +2. Going from 0 to +2 means that it probably lost 2 electrons because it's going more in a positive direction. Going positive direction means that it is losing 2 electrons. So if it's losing 2 electrons, we can't put the +2 on the left side, but rather we put +2 electron on the right side. Because if you were to put +2 here, okay, if I were to put +2 here, well, that means that it's going more towards negative, but that is not true. It's going more towards positive. Okay, so that's for our oxidation half reaction. Let's go to the reduction half reaction. In the reduction half reaction, we take the other one, we take the cobalt. And then we're going to put an arrow and find its counterpart, which is cobalt 2+. Anything to do with cobalt, we just put it here, okay? Now here on the left side of the equation, there is total charge of +3, and on the right side of the equation that we have a total charge of +2. So where do we add the electron? We're going to add 1 electron here. Why? Because it's going from +3 to -2, so it has reduced, it went down 1 value. If you want to go down 1 value, then we need to add in 1 electron in order for, we need to add in 1 electron. Now take a look at the oxidation half reaction first. The electrons in particular. There's 2 electrons there. Where on the right side, there's only 1 electron there, which means that it's not balanced by charge. Remember, we had to balance by charge, and they has to be the same. The lowest common multiple would be 2, so we're going to try to make the right side, the reduction half reaction, we're going to try to make this into 2. So how do we do that? We're going to multiply everything here by 2. That means I get 2 cobalt, 3+, plus 2 electrons, forming into 2 cobalt, 2 plus. Now that we have 2 of the oxidation and reduction half reaction balanced by the charge, we're going to put them together. Okay, we're going to combine these together. Which ones am I combining? I'm combining this reaction and the one that just got balanced together. I'm going to rewrite that here. Okay, I'm going to rewrite that there on top of one another and make sure that the arrows are in equal align with each other. So I'm going to write nickel solid, and then that forms into nickel 2 plus aqueous, and don't forget the electrons, which is 2 electrons. Same for on the left. For the reduction, I bring in 2 cobalt plus 2 electrons, forming into 2 cobalt. Don't forget the phases, right? All right, now I can add the 2 together. Now before I add, you'll notice that there's electrons, and we can one on the right and one on the left, and we can actually cancel those electrons out because the electrons are balanced. Now we can bring everything down. 2 cobalt 3 plus nickel solid, forming into 2 cobalt 2 plus nickel plus aqueous. Now we can say this final product right here, this is our balance equation right here. So we're going to do something similar, and by doing this learning check here, we have aluminum, hydrogen forming into aluminum, hydrogen. And this one, it's not even balanced by mass either. We have 2 hydrogens here. We have 1 hydrogen here. So we're going to figure that out after we have put them in half reaction. So let's go ahead and put them in half reaction. So we're going to put oxidation on the left. And we're going to put the reduction reaction on the right. In the oxidation reaction, we have aluminum solid, and that forms into aluminum 3 plus. Aluminum solid, on the left side of the equation, the charge is 0. Aluminum 3 plus is charge of plus 3. So therefore, we need to add 3 electrons on the right so that this plus 3 and 0 sort of balances out. Having 3 negatives on the right side makes this into a 0 like this, right? On the reduction side, we have hydrogen forming into H2 gas. Now notice this is not balanced by mass either, so we're going to do that first. We'll put coefficient of 2 in the front to let us know that there are 2 hydrogen plus for every 1 hydrogen gas. Now on the left side of the equation, there's plus 1 charge. However, you'll notice that there's 2 coefficients, so there's total of plus 2. Whereas here, there's no charge, so it's 0. That means I needed to add 2 electrons on the left side of the equation to make that plus 2 into a neutral charge side. Now on the left hand side, the electrons is 3. On the right side, it's 2. So we need to multiply these guys by the least common factor so that the 3 and the 2 find a common ground. And so therefore, I'm going to multiply this whole thing by 2 and this one whole thing by 3. If I multiply this whole thing by 2, I'm going to rewrite that and then place it right here. And I'm going to multiply all that by 3 and then place it right below it. Okay, so let me do that. You have 2 aluminum solid forming into 2 aluminum 3 plus aqueous plus 6 electrons. Then the reduction side, we have 6 hydrogen plus 6 electrons forming into 3 H2 gas. And the reason why I put it down here is so that I could set it up on top of one another. So I'm going to go ahead and add this all up. And if I were to add all of this up, you notice that electrons could cancel out and everything else just kind of falls down with it. So we have 2 aluminum solid plus, oh, don't forget the phases, 6 H plus forming into 2 aluminum 3 plus, and then plus 3 hydrogen gas. Whatever is left over just kind of falls down with it, okay? So we're going to try the next one. You try the next one and come back and check this video. And here is the key.